Now today we will discuss calculation of equivalent capacitance. So whenever we are calculating the equivalent capacitance, so there are 2-3 points we have to remember. First is the series and parallel combination. Another is the Wheatstone bridge. So according to the series combination, as we know, C equivalent is written as C1 plus C2 and so on. Similarly, if the capacitors are in parallel, in case of series combination, 1 by C equivalent is your 1 by C1 plus 1 by C2 plus 1 by C3 and so on. In parallel combination, C1 plus C2 plus C3 like this. And in Wheatstone bridge, what we have found, Wheatstone bridge combination, if the product of opposite capacitors are equal like this. Suppose this is your C1, C2, C3, C4 and here any cell or any other capacitor is connected. So in case of Wheatstone bridge, C1, C3 is equal to C2, C4 and there is no current on this. This is the meaning of this. So these 3 points we have to remember, then we will be able to solve the problem easily. So first of all, what is the meaning of series? Series simply we can say when two or more than two capacitors are connected in such a manner that there is no branch originated between these two. It means, for example, suppose these are the certain capacitors like this. So what we found here, between these two capacitors, none of the branches originating or generating here. So we can say simply these two are in series. This is a general idea to determine the series combination. And in case of parallel, when we are talking about parallel, means all those capacitors must be connected across same two terminals or same 2 points. For example, let this is your one of the capacitor, this is your another capacitor, and these two are supposed connected with the same common point A and B. So we can say these two are in parallel. In that case, equivalent capacitance written as C1 plus C2 like this. So these are the main basic idea. Now see the few example of determination of equivalent capacitance. This is the example number 1. Like this we are having a different set of capacitors. This is the combination. Let this having 6 microfarad, this having let 6 microfarad, let this is your, let these are the 9 microfarad capacitors. This is your 6 microfarad, this is also 6 microfarad. Let this further, it has 9 microfarad, 9 microfarad, 9 microfarad and 9 microfarad. Now question is that find equivalent capacitance between A and B. Find equivalent capacitance between A and B. So what is the problem here? First we would like to identify either any series or parallel is clearly visible to us or not. So see here, if I am talking about these 3 capacitors, 9, 9 and 9, these 3 capacitors, there is no branch originating between any of these 3 capacitors, then simply we can say these are in series. If these are in series, 9, 9, 9 and according to series combination formula 1 by C1 plus 1 by C2 plus 1 by C3, 1 by 9 plus 1 by 9 plus 1 by 9, it becomes your 3 by 9 or 1 by 3. So we can replace these three with a one capacitor that have capacitance 3 like this. It can be converted in that form. Like this we can convert in this form. It becomes your 3 microfarad. This is your 6 microfarad, and this is again 9 microfarad, 9 microfarad, this is a further 6 microfarad, and this is again 9 microfarad like this. Now further, if I am looking these two now are connected across same 2 points. Left these 2 points, see here, this is one point, this is another point. Those two plates are connected across these two. For this capacitor also connected across these two. So these two are in parallel. In case of parallel, our formula for parallel is your C equivalent to your C1 plus C2. The 6 plus 3 become your 9 again. So it will be your in that form also like this. So in place of these two, we can convert or we can write one capacitor of capacitance 9 microfarad like this, and this is still remain your rest of the remain your same. Now further, if we are looking further, so this 9 and this 9 and 9, these 9 again in series. If these 9 again in series, the 9, 9, 9 in series, it again convert into 3. So in place of these 3, we can write another, or we can convert the circuit in this manner again. This is your 9, this is your 6 microfarad, 9 microfarad, and here we can make one capacitor of capacitance 9 microfarad. Now see these two. These two again now become in parallel. So in place of these two, we can use the parallel combination formula. 6 plus 3 become 9. So finally the result will be like this. So A and B, this is 9 microfarad, this is 9 microfarad, this is 9 microfarad, and these 3 9 microfarad capacitor are in again in series. So final answer is your CAB is equal to your 3 microfarad like this. So main objective of this problem was how we are identifying which are in series and which are in parallel. So this is one of the basic idea, basic example related to series and parallel combination of capacitors. Now see another example. Now see example number 2. Now the question is that so again the same question is that find equivalent capacitance between A and B. Find the equivalent capacitance between A and B. So see from the diagram. Again, it is very similar type of diagram here again coming. So these 4 and 4, between these two capacitors, no other capacitor is connected. So these two are in series. So 4 and 4 in series, it become your 2. So finally we can make this as a one capacitor, 4 and 4 will be your 2, like this. This is 2 now microfarad. This is also 2 microfarad, and this is already given here 2 microfarad, like this. Now these 2 and 2, it clearly connected between 2 points, one point here, another point like this here, and these 2 are in your now parallel. So parallel combination, then it become your total your 4, like this. A and B, 2 microfarad, and this your 4 microfarad, and these 2 and 4 are in series. So CAB will be your 2 into 4 by 2 plus 4 microfarad. So this is your 8 by 6 microfarad or 4 by 3 microfarad. So in this manner we can easily identify which of these are in series, which of these are in parallel. See another example. Now question is given like this. This is a circuit diagram in which 4 capacitors are given. Their capacitances are also mentioned according to this. Find equivalent capacitance between A and B. Find CAB. So here important point here. How to get idea about which are in series and parallel. The first and very important point is that until unless none of the electrical circuit or none of the electrical elements are connected in a branch, so the point will remain same. Meaning is this, suppose the point A is mentioned at this location. So from here to here we can see none of the capacitor or resistor is connected. So every point can be said as a point A. So this point also can be said as A. This also can be said as A. This also can be said as A. Similarly, if this B point is a point B, so none of this thing connected here. The B point, this point also can be said as B. This point also can be said as B. And here some different point, we can say this is your D. So if we are mentioning the location of the different point like this, then it will be easy for us to understand which are in series and which are in parallel. See this capacitor. One plate of capacitor connected with a point D, another plate with a point A. Similarly, if I am looking this, so one plate of this capacitor connected with a point D, another plate with a point A. So what can be said? This capacitor and this capacitor are connected across same 2 points. See, so whenever the capacitor are connected across same 2 points, it means those 2 are in parallel. So those 2 are in parallel. So these 2 and 2 are in parallel. So we can use parallel formula, C equivalent to C1 plus C2. So this is C1, 2, C2 we can say 2. So 2 plus 2 become your 4. So further this diagram can be modified in this form. See that 2 plus 2 are 4. So in place of these 2 capacitor, we can replace with 1. So this is your 4 microfarad. So now this will not be there, and this is still your 4 microfarad, and here 2 microfarad, like this. This is B, this is A point. Now again check it here. Now if I am looking these 2, none of the branches originating between these 2, so these 2 can be said in series. So if these 2 are in series, the 4 and 4 series formula, it gives you 2. So this become your single capacitor of capacitance 2 microfarad, like this. This is 2 microfarad. This is also 2 microfarad. Now see these 2 and 2 are in parallel. So CAB will be your 4 microfarad is the final answer. So very easily we can say, or we can convert series into parallel or parallel into series. See another example. Now see another example. Here 4 capacitors are connected, each of 4 having the same capacitance C, C, C and C. Now question is that find the equivalent capacitance between point A and B. Now, so question is this, find equivalent capacitance between A and B. So again here one point is creating a problem. It is not clearly visible which are in series and which are in parallel. So as I said, we can define different nodes with a certain points. Suppose if we are defining these are the node means junction point, with certain another point, let this is called your M point, let this your N and let this your P point. Now it will be easy for us to get an idea. See, as this point, if I am talking here and if we are moving from here to here, so as we said earlier, whenever nothing is connected between 2 points in a wire, so all those 2 points or every point on the wire will be the same point. So see, from here to here, M to P, nothing is connected. So if nothing is connected, so these 2 points can be said as the same point. So if this is the point M, this point will be also M. Similarly, if I am looking this wire, see here, from this to this point, nothing is connected. So if this point is your N, so this point is also N and this point is B. The N and B are the same point. So if we want to modify this one, then we can modify like this. This is the point A. This point can be said as a M. Then between M and N, one capacitor. C. And N point is your B point. So better writing N, we can write it as B. So this is your point B. And P point. As I said, M and P are the same point. So this point again we can say your M point. Then again M to B, one capacitor like this. So see here, this is the M point, this is your M point, it is appearing, and this is B point, this is B point. It means B and B point are the same point, so we can join again like this. M and M are same point, we can join like this again. Now, M and B, one capacitor, M and B, another capacitor, M and B, another capacitor. In these 3 capacitors are connected between same 2 point, M and B, similarly B and M and B. So these 3 are connected across same 2 points. So all these 3 are in parallel. So it is equivalent to like this. A, this is let M point. From M, there are 3 capacitors are connected in this manner, like this. So these 3 are in parallel and each having capacitance your C. So these 3 parallel become your 3C, then series. So it is equivalent to like this, 3C and C. Now this point will be B and A, then CAB is your, these are in series. So series formula we can apply. So 3C by 4. In this manner we can solve. The main point here, if such type of wires are given, so we can make all those points is the same point between which there is no capacitor or no resistance or nothing is connected, then we can replace. See the next example. Now this is the circuit diagram is given, in which 8 capacitors of each having capacitance C are connected like this. Now question is that find equivalent capacitance between point A and B. So C equivalent between A and B you have to calculate. Now this diagram appears very little bit complex diagram. So what is the method here? That see, we can use here symmetry method here. What is the symmetry method here? Suppose if we have to find equivalent capacitance about any 2 point, just like here A and B point. So what can be said, if any line or any plane can be drawn which divide our whole network in symmetrically 2 part, then it is called a symmetry. For example, between A and B we have to find equivalent capacitance. So can we able to draw such a line which divide whole network about A and B point just like a mirror image? See what can be done? If I am converting this in the little bit different form. So these two capacitors, this is C capacitance. So can we write this single capacitor into two capacitor of capacitance 2C and 2C? See, likewise this is point A and B, and these are now 2C and 2C. This is also 2C and 2C, and these two in series 2C 2C become C as it is given. So there is no difference at all, only just a different way. Now as I said, can we able to make a symmetrical line? Yes, we are able to make like this. So this is the line, can be said as line of symmetry. So this is the line of symmetry. So what is the advantage of this symmetry line? So line of symmetry indicate all those points. Symmetry line does not mean only diagram symmetry. You have to see that capacitance should be also symmetrically placed. Just if you are putting a mirror here, so in the back side you will get the same type of image. See, 2C here, 2C here. This is mirror. C and C, C and C, 2C and 2C. Here also C and C. So this line is just like a mirror image which create mirror of left portion to the right portion. So where we have to draw this line? We have to draw the lines which divide our whole network about those 2 points about which we have to find equivalent capacitance. We have to find equivalent capacitance between A and B. So we should make a line in this manner so that this line can divide whole network about A and B in symmetrically 2 parts like this. So advantage is that the symmetrical line is passing from the 3 different positions here. So all those points through which this symmetrical line is passing or intersecting the circuit, those all points will be at same potential. It means potential of this point and this point and this point will be the same. So if these points can be written as, let P, R and S. So potential of point P, R and S will be same. So this point can be said as the same point. So these points can be said as the same point, and same point can be joined together, and same points can be joined together. Okay. So what I will do here, now I will join these 3 points together. So when we are joining these 3 points together, our circuit will be little bit compressed like this. See, the same diagram, see here. Now if I am joining these 3 points like this, see, in this manner. So once these 3 points are joined together, it is clearly visible which of these capacitors are in series and which of these are in parallel. See, now this 2C and C in parallel, 2C and C is also in parallel. Same thing in that side also, 2C and C parallel, 2C and C parallel, like this. This diagram further can be replaced by making a parallel and combinations. 2C and C parallel become a 3C. And here also 2C and C, 3C. So this is the point A. So between A and R, 2C and C are 3C. This is your R, 3C. Then 2C and C, 3C and the C. So it is like this. Three C and C. This is R. Same thing here also, 3C and C, 3C and C, then here 3C, and this point is your B. So this is the diagram further we got here. Now C and 3C, these two are in series. So when these two are in series, so it become your 3C by 4. So then further circuit diagram will be like this. One capacitor between equivalent to C and 3C, and another capacitor of capacitance 3C, like this. Similarly, in this manner, B point, A point, and 3C by 4, 3C by 4, this is your 3C and 3C. Now these two are in parallel. The 3C and 3C by 4 parallel will be your 15C by 4 A. And this is your point R, this is point B. So 3C by 4 and 3C are in parallel. It becomes your 15C by 4. This is also 15C by 4. So finally we will have answer CAB is your 15C by 8, like this. So this is the advantage of symmetry. If symmetrical circuit is there, so in that case we can convert or we can make a line of symmetry. By making line of symmetry, our circuit diagram will be very, very simple or very much clear, and we can make like this. Now see another little bit different approach of symmetrical circuit. See, this is the question here, it is given. In this diagram, it is a 12 capacitors are connected, which are forming a grid of a cube, or each side of the cube act just like a capacitor of capacitance C. Each of them have capacitance C here. And now question is that find the equivalent capacitance between two diagonally opposite point. So A and G are the diagonally opposite point. So what is the meaning of equivalent capacitance? In oppositively CAG we have to calculate. See, here also we will use symmetry, but this time our symmetry method is a little bit different than the previous time. In the previously we found direct straight line which divide the whole network in the two part. Here we will see the charge distribution. See, between A and G point, if we have to calculate equivalent capacitance, it means if I am assuming a battery between A and G point, so through the cell if Q charge enter, so from the other terminal Q charge has to leave. But how the charge will go through the cell or through the circuit here. In the circuit, from A to G, number of paths are available. So first we will identify which of the paths are unique path. See, unique path means none of the branch as well as none of the node should be common in those paths. So see, if Q charge enter here, so we can say one path is your A to B, then charge can go B to C, then C to G. So we can write like this: one path available A to B, A to B, B to C, and then C to G. Now, if I am looking at another path, see, A to D, D to H, H to G, A to D, D to H, then H to G. And third path, A to E, E to F, F to G, A to D, A to E, E to F, then F to G. So what we found here, there are three unique paths are possible. If we are taking any other path, that path will not be the unique, because any of the branch or node may be common. See, you can follow any of the other path. Suppose we are taking that path, A to E, E to F, F to G, then what we will find? That path already covered. But if we are following another path, A to E, E to H, H to G, so A to E, A to E, E to H, then H to G. So see here, H to G and here also H to G. It means in these two paths, this branch is common. So these two paths cannot be said as a unique path. So we should not consider this path here. So unique path means all paths should be identical, not identical. So after identifying those unique paths, and now check either the distribution of capacitance on those three paths are similar or not, and the length of path are similar or not. So see here, as we are moving from A to B, A to B and A to D and A to E, A to B, A to E and A to D, to come to the next node junction point, D, E and B. See the distribution of capacitance from B, B to F C, B to G, B to C, another C. Similarly, E to F C, E to H also C. From D, D to C, one capacitor C, D to H, C. It means further if we are moving from A point to next point, then next to next point, so what we found, distribution of capacitance are same and similar. So these paths are called similar path. It means similarity is there. Now, once the similarity is there here, so it means the distribution of capacitance will be similar. Distribution of capacitance, distribution of charge will be similar. The total charge enter here your Q. So in this path, Q by 3 will go through this path, Q by 3, and here also Q by 3. So distribution of charge will be your similar. Now, once Q by 3 is reaching here, see, from B to G point, one path is B to F, F to G, another path is B to C, C to G. Then what we found here, these two again separately the similar paths are there. So being the similar path, again the charge will distribute in the similar manner. So half of the charge will pass through this path and half of the charge will go in that. The Q by 6, here also Q by 6. Similarly, Q by 3 comes here, in this path Q by 6, this also Q by 6, and from this here Q by 6, and this is again Q by 6. Now, Q by 6 charge coming here, Q by 6 again coming. So then sum of these two are Q by 3. Here also Q by 6 from this side, Q by 6 from this side. the q by 3, and here also q by 3. So again q by 3, q by 3, q by 3 become your q. So this is the distribution of charge because of the similarity. Now we can apply Kirchhoff law in any of the loop. We are starting from here. So minus q by 3c, then here minus q by 6c, then again here minus q by 3c, then finally we are reaching here plus v, this is 0. So we can have 5 by 6c into q, this is equal to your v. So as we know, q is equal to your v into c equivalent. So q by v is equal to your c equivalent. So that give you c equivalent is your 6c by 5. This is the meaning of this. So this is the final answer. So here the symmetry is your charge symmetry we have used as compared to your diagram symmetry. So now see another example. Next is another example that is a little bit different type of questions here. Here different plates are given and we have to find equivalent capacitance. See, these are the plates are capacitor like this. There are 6 plates of capacitor, one plate kept like this, another plate like this, like this. These are making different capacitors, one like this, another like this, in this manner. Total we are using 6 plates here. So let these two are connected together and these are connected together, and question is that find the equivalent capacitance between A and B. So find CAB. So here given is that all are identical plates, all are identical plates of area A, and gap between the two plates is gap between two plates is D. So each set of plate have capacitance epsilon naught D. This is the each set of plates have capacitance like this. Now we have to find equivalent capacitance between A and B point. So here it is difficult to identify which plates are in series and which are in parallel, as well as our regular diagram is not like this. Here the plates are kept like this, one plate, then below that another plate, then third plate, fourth plate, fifth plate, sixth plate, like this. So what we can do first, we will reconstruct this diagram as per our regular type of diagram. So it will be easy to see the whole picture here. So first we will make a numbering of the plates. Total 6 plates. Plate number 1, 2, 3, 4, 5, 6, like this. Now I will reconstruct the diagram in the regular form. So as plate number 1 is this, so I am making vertically plate number 1. The plate number 1 is making a capacitor with the plate number 2, like this. So plate number 1 in front of that plate number 2. But plate number 2 is again making with a 3. So it means plate number 2 is participating 2 times. One with a 1, another with a 3. So I will make plate number 2 2 times, 2 with a 3. Same thing for 3. So just below the 3, 3 and 4, then 4 and 5, then 5 and 6. In this manner, first we can draw. After that, since the plate number 2 3 and same plates. So it will be convenient if we can join these two plates together. 2 and 2, 4 and 4, 3 and 3, and 5 and 5. This is a normal procedure. So first we have to construct the diagram like this. Now as per the question, in the question they are saying plate number 1 is joined connected with the plate number 3. So clearly we can join 1 with the 3 and plate number 2 with the plate number 5. So plate number 5 and 2 with a 5 like this, and their common point set as a B. Now plate number 6 as a point. So now this type of diagram we are having. Total we have 1, 2, 3, 4, 5 capacitors. Each capacitor have capacitance C like this. Now we can easily identify which are in series and which are in parallel. First see the diagram. Interesting point here. So whenever there is a junction, better we can define those junction with a separate point, so it will be easy or convenient to say the series and parallel combination. So this is the B, this point is also B, this is also B, and from here to here this is also B. Apart from that, any other junction, this junction, that we can say D, no problem. So see here, this is one capacitor between B and D, another capacitor between B and D. It is clear these two are in parallel. If these two are parallel, C is of this, C this. C and C become your 2C. So in place of these two, we can make one capacitor of capacitance 2C. So further we can reconstruct the diagram. Similarly, check it here. If I am looking from this to this, from here to here, no other capacitor is connected between these two. So these two are in series. C and C will be your C by 2. So we can say between B and D one capacitor C by 2, between B and D another capacitor your 2C. So this is your B point and this is your D point. Between B and D one capacitor 2C, and this is the point B. Again B and D another capacitor, that is C by 2. The B and D another capacitor C by 2. Then see, B point is connected with a point A. B point is connected with a point A with one capacitor. With a one capacitor A that have capacitance here C. Now see what happened. B to D one capacitor, and then B to D another capacitor. So what will be the equivalent capacitance? They are asking equivalent capacitance between A and B. It means if I am joining a cell or a battery between A and B, so what we will get? There is no charge on these two capacitors. No charge, because these two are coming in the same point here. So whatever charge flow, that charge flow across only this capacitor. So these two capacitors are not playing any role. So these does not have any effect in the circuit, either these two are present in circuit or not. So finally this is equivalent to your one capacitor which is connected between A and B. The CAB will be here C, and this value epsilon naught A by D like this. So this is the meaning of that. So first of all, these plates we should rearrange in this manner, and then these can be easily calculated like this. See another example, from that you can understand in the better way. Now see another example. In this example also we are having 6 plates, 1, 2, 3, 4, 5, 6, and all are the identical plates having area A and gap between the plates is D. So the capacitance between the two plates can be written as C is equal to epsilon naught A by D. Now again, if we have to solve for this, so we want actually equivalent capacitance between A and B point. So then see how we can rearrange this diagram again. So as I said earlier, first numbering it. Just give the number to the plates so that it will be easy for us to make an equivalent diagram which is same as this one. See, the plate number 1 making a capacitor with a plate number 2. Plate number 2 again making with a 3. So plate number 2 we will make once again, and this is making with a 3. So we will make plate number 3. So 3 with a 4 also, 3 with a 4 also. Similarly, plate number 4 with a 5 and 5 with a 6. See, plate number 4 with a 5 and 5 with a 6 like this. So these are total 5 capacitors we are having. Since plate number 2 and 2 are the same plate, plate number 3 and 3 also same, 4 and 4 same, 5 and 5 same. So we can join these plates like this. It is easy in this manner. We can join like this. After that, this is the basic diagram for all 6 plates. After that, according to the problem, plate number 1 is connected with a plate number 4. The plate number 4 is here and this is your 1. We can join plate 1 with a 4. Similarly, plate number 3 with a 6. The plate number 3 with a 6 in this manner. Now plate number 2 given a name A, plate number 5 given a name B. Plate number A given a name A and plate number 5 given a name B. So our aim is determination of equivalent capacitance between A and B. Now see how to solve this problem. So if we are looking directly, so I think none of the capacitor visible which are in series or which are in parallel. See, any two of that. If I am talking about this and this, it is not clearly either series or parallel. So one thing we can do, we can reconstruct the diagram. So first we have to define nodes with another name. So A point here, this point will be also A, and this is one another node. So we can say let this here M, and this another node we can say N. B is this, so this point is also B. Now I am reconstructing the diagram with another way. See, plate number A, it means first is the terminal A. From terminal A, one capacitor is connected M. In one plate of this capacitor with A, other plate of this capacitor with M. You see, let this is point M. One plate of with A, another plate with M. Similarly, A and N also, one plate of capacitor this with the point A, another plate with a point N. So we can have one more capacitor between M and A like this. Then see, for third capacitor, one plate with a N, another plate with a M. So between M and N also one capacitor like this. Next, between M and B, one plate with a M point, another with a B point. So one plate with M point, another B. Let this point B. Finally, this capacitor, one plate with a B, another with a N. One plate with a B, another with N like this, and now we have to find equivalent capacitance. See here, all of the capacitors having same capacitance. See, very interesting point here. This is C, this is C, this is C, and this is C. So this is the condition for Wheatstone bridge. If opposite capacitor, product of opposite capacitors are equal, then there is no charge on the middle one. So there is no charge on the middle one means point M and N are at same potential. So either we can join those 2 points or we can remove capacitor C, because in capacitor C there is no charge. So this is just like a useless. So this further can be made like this, in this manner. Finally, B point and A point, C and C, C and C. So these two are in series, the C by 2. These two are also series, C by 2. Then these two are parallel. So finally, CAB is equal to your C equivalent like this. So in this manner, we can convert. So this is the another question here. Now see one another example related to the plate. So you may have much more clarity about this. This is the diagram given. This is the arrangement of different plates. Here also we are again using 6 plates, 1, 2, 3, 4, 5, 6. But now in this time plates are arranged or plates are connected in the different way. Then how we can get the equivalent capacitance between A and B? So we have to find equivalent capacitance between A and B. So again we will make the rearranged diagram. So first, as per our method, we will make 6 plates, and that 6 plate give you 5 capacitors like this, 1 and 2, 2 and 3. Then between 3 and 4 like this, then 4 and 5, and finally 5 and 6. Next step is your join plate number 2 and 2, because these are the same plates. Join 4 and 4, join 3 and 3, and join 5 and 5. After doing this, join according to the given problem. First and 6 connected, and these are given name B. First and 6. These are given as a B. Then 2 and 5 given a name A. 2 and 5 like this, given a name A. And third is your 3 and 4. 3 and 4. So why not we can join directly 3 and 4. So very interesting point here. When 3 and 4 point are joined directly, so it means, as we know, in case of capacitors, facing surface of the plates have equal and opposite charge. So when we are joining like this, so whatever charge on a one is a positive, another your negative, that will neutralize. So this will not remain as a capacitor. So it acts just like a simple wire. So this now capacitor there is no use, or we can say this become your short circuit. So if again we are reconstructing the diagram, then the diagram will be this. Before that, first we will define all the points. This is point A, this is point A, and this is point B, and B, this is also B, and no other junction in between, and this is just like a wire. So first of all, this point A, this is also A. So see, important point. So one capacitor between A and B. So let this your B. One capacitor between A and B. This is this capacitor. Then A and A. This is no more capacitor. These two left and these two are in series. C and C become C by 2. A and A. It is coming also A and A like this, C by 2. So these 3 over. Now another U between A and B, one capacitor. Between A and B, one capacitor. So see, these plates of capacitor are connected with the same point. So potential of this and this will be same. So it will not have any charge. So no charge here. So it is also useless. So no use of this. So finally we will have two capacitors between A and B, and these two are in parallel. So C equivalent will be your 2C. This is the answer. So in this manner we can calculate equivalent capacitance in case of plates are connected together. Now see different type of another problem. If the capacitors are in a series as well as they are making infinite series, see the diagram. Now this is the infinite series. In infinite series, C1, C2, C1, C2, C1, C2, this type of capacitor reoccur up to infinity. And now the question is that find equivalent capacitance between A and B. So in that type of questions, as the capacitors occurs regularly in a regular interval of, you can say, set, and their value also your same C1, C1, C1 like this here, C2, C2, C2. So what can we do in this case? We can make a set of capacitor which reoccurs. See here, if I am making, this is the one set of capacitors, this is the another set of capacitor, and these type of sets of capacitors are reoccurring up to infinity. So we can say a group of reoccurred capacitors are connected up to infinity. How many such sets are possible? Infinite sets are possible. In the infinite such set, if I am removing one of the set or adding one of the set, then the number of sets remain your infinity. The same logic we are applying here. So what we are doing, let CAB is your C. If CAB is your C, so now if here we are considering two another point here, E and F, just forget about the previous case. Now if E and F we are comparing here, so what we are getting, then how much series now long? Further it is your infinitely long series. See, if I am looking here E and F point, if we are looking here E and F point, our series will be your further your infinity. So this your further infinite series. So this series and this series. So if CAB is your C, then CEF must be your C, because our series still remain your infinity, and that type of reoccurrence of the capacitor will be there. So if CAB is your C, then the equivalent capacitance between E and F will be also C. So finally we can have diagram like this. So A and B point are like this, C1, C2, and these are the E and F point. So between E and F point we can join value C like this, because CEF we have assumed C. So finally we have to find the value of C, because this is our requirement. So in that case we can say these two are in series, parallel, then series. So this is your C1, and then these two when parallel, it will be your C2 plus C. So here we are getting CAB is equal to your C1 C2 plus C by C1 plus C2 plus C, and CAB we have assumed as C. So this is equal to your, the C is equal to C1 C2 plus C1 C by C1 plus C2 plus C. Now further we can simplify this one for a value of C. So C C1, C C2 and then C square. So this equation will be your C square plus C2C minus C1 C2 is equal to your 0. So that equation we can simplify. The C is equal to your minus C2 plus minus C2 square plus 4 C1 C2 by 2. This is the value of C likewise, and this we have to calculate. So these are the values as capacitance in unknown value, C1 C2 value. We will solve, or we can try one question by considering a numerical value in place of C1 C2 and taking another different type of combination. See the next example here. Now see, this is another example of infinite series. Here we are using 3 capacitors, 2 microfarad, 1 microfarad and 2 microfarad. And this type of set of capacitors here goes up to infinity. Now if we want to find equivalent capacitance, so how to get? In the same way, see here, if I am looking the set of capacitors, so here one set of capacitors having 2 microfarad and this is your 1 microfarad. Same set here also, same set here also. It means these type of sets, the set of 3 capacitors are reoccurring, and that reoccurs up to infinity. How many such sets possible? Infinite sets are possible. So if again, if CAB, if I am assuming let C, and here we are taking let E and F point, leaving the one set of capacitor. Suppose if I am leaving the one set of capacitor, so from E and F point onwards, from E and F point onwards, our series will still remain your infinity. Since our series still remain your infinity, so whatever equivalent capacitance came between A and B, same type of equivalent capacitance will come between E and F also. So we have assumed between A and B as a C. So same value we can have between E and F, that is also C. It means that diagram further can be replaced in that manner. And this is your E and F point. The E and F we can write one capacitor, your C value, and this is your 2 microfarad, this is your 2 microfarad and this is your 1 microfarad, A and B. Now these two are in parallel. So this is your C plus 1 and this is your 2 microfarad A and B. Now these 3 capacitors are in series. If these 3 are in series, so and between A and B, as we have assumed your C, so in these 3 are series, so 1 by C is equal to your 1 by 2 plus 1 by C plus 1 plus 1 by 2. So this is your 1 plus C plus 1. Now simplify this. When we are simplifying this one, the C plus 1 is equal to your C plus 2. So this is your quality equation you will get. C plus 1 is your C square plus 2C, or that is nothing, C square plus C minus 1, which is 0. So C is equal to your minus 1 plus minus 1 plus 4 by 2. This is the roots of value of C. So here minus value is not acceptable for the C. The capacitance of C will be your minus 1 plus root 5 by 2. This is the equivalent capacitance between A and B if our series is your infinite. So these are the different type of example related to calculation of equivalent capacitance